We'll start at 4:30. Yes, good evening, everyone. Over to you, Nidhi.
Hi, everyone. A very, very warm evening and a very warm welcome to the session on Thinking and Working Scientifically by Ms. Siobhan Parker. Ms. Parker has over 30 years experience in teaching and management in a variety of schools. She has been working as an education consultant for the Cambridge Assessment International Examinations, HarperCollins, and the British Council. She is running primary maths and science workshops across Middle East and South Asia. Before I invite Ms. Parker for conducting the webinar, a few set of instructions for participants on both Zoom and YouTube. Please use the chat window to respond to the questions asked during the webinar, post your queries and feedback. And now I would request Ms. Parker to take the session forward. We welcome you, Ms. Parker, and would request you to take it forward.
Thank you very much. Thank you very much for that lovely introduction. Hello, everybody, and welcome to our science webinar today on thinking and working scientifically. Thank you for joining us, and also thank you to HarperCollins India for inviting me. Yes, my name is Siobhan Parker, and I work as a teacher trainer with HarperCollins. I'm very excited to be joining you today from thousands of miles away. I'm not in the UK at the moment. I'm actually staying in Norway, so I'm even further from you, but I do feel that you're quite close out there in this cyber world. As well as using the chat box and the Q&A box, you might wish to have pen and paper at the ready to write down a few ideas. I'm hoping that you have already used the chat box to look at this young learner or the photograph of the young learner that you can see there on your screens, as well as the bits of equipment that are beside her, and for you to tell me what you think she is doing there. I'll just have a quick look at the chat box to see if I've got, okay, thank you very much, Shalini. We have got creating a volcano. Yes, okay. How is she creating this volcano? You probably know this lovely experiment that you can do. You may have already performed it with your learners or modeled it with your learners. You can do this online if you show them what you're meant to do, and then they can be using that. Oh, thank you, Kasturi. Yes, she is using baking soda. Why is she using baking soda? Okay, fizzy soda, it's the fizzy soda experiment. Okay, I want to dig deeper here. Okay. Why are we using the fizzy soda experiment? Make the link, please, with the volcano. Okay, yes, baking soda and soap will create effervescence. Carbonates, chemical reactions is good. Okay, yes, she's causing a chemical reaction that would look like a volcano erupting. Okay, so the bubbles in the washing up liquid are from the carbon dioxide formed by reaction of sodium bicarbonate and vinegar. Okay, gases are produced. Right, that is fantastic. Okay, basically, this young learner is behaving like a scientist. Look at what she's wearing. Okay, and you will figure out during this webinar why I've used this photograph of this young learner, because she is thinking and working as a scientist. She's wearing goggles. She has been using equipment. Okay. Thank you, Sunti. Yes, she is wearing eye goggles too. She is protecting herself. And this is like a real scientist would do, okay, is they would use given equipment appropriately. She's also been following instructions and she's been making predictions. So this will bring us on to my next slide, okay, which will be explaining to you the outcomes of this webinar, okay. We're going to be exploring the new skill strand, thinking and working scientifically, from the new Cambridge primary and lower secondary curriculum. I will be focusing mainly on the primary in this session, but it doesn't mean to say that those thinking and working scientifically skills they are started at primary, but they are then explored at a deeper level in lower secondary. I'm going to give you plenty of new ideas for incorporating thinking and working scientifically into your teaching and learning, most specifically using Collins International primary and lower secondary resources. You will also have the opportunity to have your questions answered during a discussion at the end. So please do use the chat, the Q&A box as we go through, okay? There will be a number of times I'll be asking you some specific questions, and then that is when you use the chat box, okay? So you're not going to be let off the hook here today, because I'm asking you some questions immediately using Mentimeter, okay? The first question is, can you recall how you learned science? And use this code, please, 82928477. And my colleague will be showing us the results. Can you recall how you learned science? Because in fact, it's taught very differently these days.
So I repeat the code for all of you. It's 82928477. All that you have to do is please log on to www.menti.com and enter the code 82928477.
That's great. Okay. It does often take a little bit of time to actually log on to Mentimeter. But as you are logging on, you can be thinking about, like, okay, rote learning. Yes, some people, oh, this is great. So inferring, so deducing, yes, exploring, textbooks. So this, we've got a balance again, like last week, between rote learning, textbooks, as well as exploring and doing experiments. Observation, interesting observation, actually. I hope that it wasn't just observing your teacher doing the experiments, but it was you as well doing the experiments. Drawing diagrams. Yes, okay, that's interesting. We're going to pick up on the diagrams in a moment as well. So we've got a very rich balance here, okay? Theoretical mostly, yes. Very interesting, because now we're moving away from the theory by getting really stuck into doing experiments and learners working out the answers themselves. This is great, okay? Making notes in a new book, okay? Yes. Okay, can we move on to the next question? It's such a shame.
Ms. Parker, before we move on, there is an answer. There are actually a lot of answers on YouTube, and one of One of it is from Miss Smita, and she
Ah.
said observing things.
Observing things. Thank you. Yes. Now, as I'm saying, yes, hopefully it's not just observation, but it's also learning by doing. Somebody has said here, my teacher inspired me, hands-on experiments. This is great. Okay. Textbooks. Yes, textbooks have got a great role, as you will see. Yes, acid. Okay, that's interesting. Salt. Can you recall how you learn science? Shall we move on, please, to the next question? Okay, so it's a new code, 58126273. In your experience, what difficulties do your learners experience with science?
So I repeat the code for everybody. It's 58126273.
Concept learning, yes. Okay. And often, yes, with concept learning, it's how we explain it. Again, if you don't feel too confident with explaining concepts, in the teacher guide from Collins Primary and Lower Secondary Resources, we have got a lovely section at the beginning of each lesson, which is called Scientific Background, okay? And from that, it will give you the explanation behind a certain concept, okay? And that will help you with your teaching of that concept, okay? Analyzing data. Interesting, okay. Again, all the resources here are very clearly structured to help our learners analyze data in terms of templates that they'll be filling in, and also the questions that we can ask during the lesson. The periodic table, I wouldn't worry too much about that at this level, at primary. Yes, it does focus in lower secondary, or appear in lower secondary. It's a lot later on. Okay, restricted equipment. Thank you for that. Yes. Again, this webinar will help you think about the equipment that you have got around you. That is very much at the core of the Collins resources and also the Cambridge curriculum. Is science doesn't have to be conducted in the latest up-to-date science lab. We can do most of the experiments in our classroom or at home. Okay, this is very rich again. I do love Mentimeter for this reason, actually, the way that we have got answers pouring in the whole time. Okay, the links between topics. That is an interesting one. We, again, in the teacher guide, really do explore those links and help learners build connections, okay, between them. Okay, I think I've covered most things there. Okay, formulations. Again, it's not so much a focus at primary. Yes, we start talking about formulas in lower secondary, but we are laying the foundations all the time. Okay, let's move on to the next question, please. It's the last question on Mentimeter. And
as we are going to the next question, I would just like to read out an answer from YouTube. So Ms. Rekha has written, all concepts cannot be analyzed by performing like space technology and many hypotheses. And Mr. Daniel has written analyze and relate the concept. Ms. Sahai has written visualize the concept.
Visualizing, yes. So it's not, yes, it's, yeah, getting them to see the connections or to actually, yeah, work things through. And this is so much at the core of thinking and working scientifically. I'll be explaining this in a bit more detail in a moment. Okay, so the last question is, okay, what difficulties do you expect to experience teaching science using the new Cambridge curriculum? How familiar are you with the new Cambridge curriculum? It's we started this month with it. Have you found it difficult so far? Have you had to bridge the gap between the old curriculum and the new one? So if you could perhaps answer in Mentimeter using the code 58733955. So it's 58733955.
And meanwhile, everybody's answering, I guess. Ms. Komal Mishra has written experimenting.
Yes. Okay. Yeah, because there's so much more focus now on the learners doing the experiments and how we can like carry out those experiments, especially if you're teaching online. And also, great, we've got some skip old methodology, more experiment-based, lovely. Okay. Oh, that's a lot come through there. Thank you. Transition. Yes, we have got from Cambridge itself, Cambridge International itself has got some very good documents about transitioning from one curriculum to the new one. So there is lots of support from Cambridge. Also, the Collins resources do bridge that very well for you as well. I have got some slides on that later. Time management, yes. Again, with time management and time constraints, it comes that, yes, we do suggest in terms of the 3 or 4 content strands in our teach guide, we say that you should spend perhaps say 40 minutes to an hour, and we go through the distinct strands, but you can plan that and use it flexibly yourself. Okay. This is lovely. A very good evening. I've got a thank you. Okay. Connecting to reality. Yes, connecting to the real world around us. Yes, so making science a lot less abstract, but more concrete. Okay, experiential learning. Okay, repetition of concepts. So that's interesting. Okay, because we do need to repeat to reinforce knowledge, missing concepts. I think I might have covered that already. So we have got here another, like I would say, imbalance here between repetition of concepts and repetition. Okay, that's interesting. Exploring TWS in the new strands. Okay, earth and space concepts. Okay, that's not too new, I would say, because they have always been covered at some point in the curriculum before, but this time they have been kind of just drawn out from, say, the science, from the chemistry section before, or biology and the environment, and a new strand has been made because it was felt that more focus should be given on Earth and space. Right, this is great because I've now got a lovely understanding of where you are coming from, okay? And now I'm going to go back to my screen share, okay? And please do say, okay, if you can see the screen. Can you see the screen?
Not yet.
Ah, that's my mistake again. Okay. Let me go. I always share this. I always think I've shared the screen, but I haven't. So, okay. Okay. And I think
it's visible now. Yes.
It's visible and it's not visible. Okay. There. Okay.
Yeah.
Right. Thank you very much, everybody, for your patience there. And I've got a lovely understanding now about where you are at right now. I'm going to build on that during this webinar. I'd like to just take a step back for us to think about this new strand, thinking and working scientifically. Here, I'm giving you on this screen an overview of the science curriculum. And this is really useful for you to illustrate the approach that Cambridge International has taken in terms of teaching and learning science. As you know, there are 3 categories of strands, and all of these categories support learners in understanding and investigating natural phenomena and provide them with the foundation for developing future scientific skills and also knowledge and attitudes. So we've got a skill strand which is called thinking and working scientifically. And you can see that that is woven into the 4 content strands of biology, chemistry, physics, and then that new one, Earth and space. Now, we have a context strand, you see, here at the bottom. And that context strand, whether it's in the context of biology, chemistry, physics, or Earth and space, is best learned, or science is best learned in context itself. In the Commons Resources, we do focus as well on science in context, and we have special units or special lessons dedicated to that. But my focus today is mainly on thinking and working scientifically. This is what brings science alive, okay, or brings those content strands alive. It's really at the core of the curriculum, okay, and it underpins everything in terms of active learning, in terms of metacognition, and in terms of assessment for learning. It's moving the learner to center stage. And this is because there's been lots of evidence around the world that learners learn science best or content best when they are doing the learning, or when they are carrying out investigations, when they're thinking about something and working scientifically. Think about that young learner at the beginning and what she was doing. She was carrying out that volcano experiment herself, and she was able to talk about what she was doing, or even before, and what she was going to predict would happen. Now, thinking and working scientifically does not have to be in every lesson, okay? But it would be very difficult to have a lesson without it. So let's think now about what thinking and working scientifically really is. So here is a diagram that will show you, okay, what it is. You may have seen this already. It is in the teacher guide, okay, how it has been broken down into 4 different steps or sub-strands rather. Sorry, this is in the wrong order. We have got, first of all, scientific inquiry, purpose and planning, okay. Then we have got carrying out scientific inquiry. There's going to be a lot more about this in a moment as well. Then we have got analysis, evaluation and conclusions. And then our last substrand, which is completely new to science inquiry or thinking and working scientifically, is models and representations. You would already be familiar with science inquiry, but now it's become a lot more granular, okay? So in terms of the new curriculum, it's been broken down here into logical steps, okay? So we've got the purpose and making plans, carrying out of the experiments, and then thinking about the experiment afterwards. So let's look first of all at the new substrand, which is called models and representations. I don't know about you, but when I first heard about this new substrand, the idea of, or the image of the skeleton at the back of the science lab came to mind. And it was like when I was at school a long time ago, we had that dusty skeleton in the cupboard that would only come out once a year. Models and representations is a lot more than that. Now, perhaps you would like to use the chat box to tell me, why do we use models? Okay, it's not just about getting learners to draw the planet system or labeling parts of a flower, or here, as you can see here, for a screenshot from one of the books, I think it's in stage 4, the electrical circuit, getting your learners to copy that and draw it. It's a lot more than that. Now, let's see what answers I've got in the chat box. Understanding better visually, good, okay. Learners can understand better with models for easy understanding, yes. To comprehend, to apply, great, thank you for being so active here in the chat box. Okay, so we are used to using models, you're right, in our teaching, but now we're teaching about models too. Okay, the use of models in science helps us to think about objects, systems and processes. Some of you have already said that, thank you. Okay, we'll be raising learner awareness to see that models aren't necessarily perfect, okay? And where the model we are using, it may need adapting, okay? So you'll see later during this webinar with using the Collins resources that you'll see that it's full of appealing models to use with your learners. Okay, so let's move on to the next substrand. Okay, and that is about science inquiry. Okay, in fact, I've put the 3 substrands together here. Okay, so we have got here the science inquiry, purpose and planning, carrying out scientific inquiry, and then the analysis, evaluations, and conclusions. You can see, well, later you will see that the steps are smaller and are more progressive. Clearly, we need to get used to these different types of inquiry. But rest assured that Collins has covered it for you, and they have done the hard thinking in making sure there's an even coverage throughout all of the books, okay? Even coverage of those learning objectives, okay? So I just want to go into even more detail about scientific inquiry, okay? And thinking about purpose and planning, okay? So before starting an investigation, we must plan the what and the why. Firstly, we're getting our learners to engage with what they can see immediately in front of them. As you can see here, I have got a stick of celery in a vase here. We're asking them questions about the world around them. So here, they're going to be making predictions. They use the template on the right to help our learners to see how plants absorb water. On the left here, you can see a cartoon, and you can see a young learner thinking about the risks when planning investigations. So as well as thinking about the different types of scientific inquiry skills the learner will be using. There's more about this on the next slide, okay, because I do feel it needs a bit of special attention, okay. So after they've done the planning and thinking about the risks, this is where the fun really does start. Look at this young scientist, okay, here. We really want to engage and motivate and excite our learners by carrying out investigations. And not only do we want to develop learner awareness of carrying out practical work safely, knowing which measurements to use and to know which equipment to use in an investigation, we want to train them how to record observations and measurements. Keep that in mind, please, for when I show you some of these specific resources from Collins. Lastly, I'm going to just explain a bit more about analysis, evaluation, and conclusions. At primary and lower secondary level, are we expecting our learners to be able to analyze data like this? I'll just go quickly to the chat box. Okay. Okay, and if you could just write in the chat box, yes or no. Do we expect our learners? Okay, thank you, Kasturi. You're first off the mark. Okay, right. Okay, no. Jayashri has said no. Okay, yes, partially. Good answer. Okay, yes. Okay, I could build on that. Okay, but for the sake of the rest of the webinar, I will just very quickly say, we're not going to be asking them to analyze data like this, okay, at primary and lower secondary, but we are providing the foundations here so that they can later on in their studies do so. Okay, here at this level, they're going to be identifying patterns. This is really important, and I'll focus again in my next few slides, okay, about making conclusions as well as presenting and interpreting results. So you can see from this photo, okay, let me just bring it up. Okay, here, of a young learner who has been asked to carry out his cars, or to sort out his cars and lorries in terms of speed and how fast they travel down a ramp. Okay. I said I would just talk to you very briefly about the different kinds or types of science inquiry skills. These skills are embedded within the scientific inquiry substrands, okay? We've got research. Now, if you think about researching like using secondary resources, so that is for evidence to answer questions, okay? So for example, it could be something from the internet, or it could even be the textbook itself. We talk about fair testing, and that is identifying the effect of changing one variable on another while attempting to keep other variables constant. Somebody already said one of the challenges, okay, was observing over time. I do think that is a challenge with teaching science, okay. So that could be, for example, experimenting or showing a plant and how it needs water, and not watering the plant and observing the differences in the plant over time. Pattern seeking as well is identifying patterns in measurements and observations, okay, where not all the variables can be controlled. So really, we'll need to get used to these different types of inquiry. But please do spend time familiarizing yourself with it, with the substrands. Again, they are listed in the Collins resources, and I will show you. Okay, here, I'd like you to tell me, using the chat box, okay, looking at the screenshot on the right, like hopefully you can see it, observing the moon for a week. Can you tell me which scientific inquiry skills do you think the learner used here? This is actually taken from one of the Collins resources worksheets, okay. They had to observe the moon for a week. Now, let's go and have a look in the chat box, okay. Observing over time, that is lovely. Observing and recording, fantastic, okay. Yes, they've also had to, yes, record data, that's right, and also analyze the data, okay, and they had to plan as well, okay. Thank you very much. They saw the pattern, okay, of the waxing and the waning of the moon. That is lovely, over 1 week. Thank you, okay. Now, I think learners will love knowing which science inquiry skill they are using. So if you can, get them used to using the terms from a very young age, okay? You may wish to have some word cards displayed around the room and ask them which scientific or science inquiry skill were they using at a particular point in the lesson. So now, just to make sure that we're all listening, okay, it's time for a quick quiz, okay? How many substrands are there in thinking and working scientifically? I'll just have a quick look at my chat. 4, brilliant. Okay, you're all on the ball there. Thank you. Okay, right. Okay.
Only Ms. Dipali has said 5, otherwise everybody else has written 4.
Okay, that is, yep. For science, for thinking and working scientifically, yes, there are 4. And which ones are they? Okay, you can just use abbreviations. Okay. Right, scientific inquiry is broken down a bit. Okay, thank you, Kanchan. That's the content strands. Okay. Okay, models, brilliant. Model and representation. Models and representation, science inquiry, and that is broken down into those 3 substrands, okay, which are purpose and planning and carrying out investigation. And what's the last one? For science evaluation. Thank you. Lovely. Okay, so that's great. We're all spot on there. Okay, thank you very much there. Okay, so let's think now how we can use thinking and working scientifically when we are working with Collins resources. Before I go on to that, I would like just to say, mention about progression in learning with the 2 different levels of books here. The progression of the learning objectives within thinking and working scientifically, or in fact, in any of the other strands, enables the development of knowledge and understanding through that spiral approach, by revisiting and engaging with topics and skills at deeper levels and in different contexts across the stages. The new curriculum has been reviewed to ensure that the transition from primary to lower secondary has become a lot smoother and more gentle. So really, it doesn't look like a huge step going from primary up to lower secondary. So Cambridge has worked on making that progression a lot smoother, and Collins has addressed that within the resources. Now, before we launch into the resources, I'd like us to think about carrying out experiments. Do we need to have a specialist lab? Okay, whoops. I'm hoping, I'll just have a quick look at the chat box. You think, yes, we need a specialist lab. Okay, lower secondary, I would say it is more beneficial if you can have a particular room dedicated to carrying out experiments. Okay. At primary, that is less so. And Collins is very mindful of that and gives you plenty of ideas that you can carry out experiments in your homeroom or for learners to do at home. So let's look at some of the resources now. And you can see here, I've got screenshots from the 6 stages at primary level, and then also for lower secondary, we have stages 7, 8, and 9 student textbooks, as well as the workbooks and the teacher guide, the all-important teacher guide. I feel that Collins Resources really comes into its own and plays a huge role in helping your learners to think, work, and behave like a scientist. There are opportunities in every activity in the student book for learners to think and work. The teacher guide, there is guidance in all the activities, okay, as well as guidance for thinking and working scientifically. There are ideas for starter activities and plenaries within the teacher guide, okay, and these ideas over the next few slides all come from the teacher guide, the student book, and or the workbook, from Collins Primary and Lower Secondary. And then there's a few experiments that have been carried out by some of my learners that I've been teaching recently, okay, and some even online too. So just very quickly, I will show you how Collins has really thought about thinking and working scientifically in the new resources. You can see that here I have got a screenshot from the student book and then also from the teacher guide. So every lesson plan in the teacher guide clearly lays out the thinking and working scientifically learning objective. Sorry, that's my alarm going. It's saying that I haven't got much time left. Okay, so we have got that covered. Okay. There's also, I think, another unique feature of the teacher guide, and that is that, sorry, of the series. Here you can see that I've highlighted from the teacher guide the different topics that are taught here at this particular stage. And we've got Our Living World, Healthy Eating, Materials, okay. But there is a focus in each unit, okay, where there is a specific lesson with a focus on thinking and working scientifically. Okay, so you have got here planning a fair test, models and representations, choosing and using equipment. So I like that feature that we have got that woven into the resources. Also at the front of each teacher guide, we have got a learning objectives matching grid, okay, to show you specifically which unit would cover a particular learning objective from thinking and working scientifically, okay. There's also in the extended teacher guide, and this version, extended teacher guide, will give you interactives, PowerPoints to develop certain, you could use it to develop certain models, or for them to be thinking about a scientific concept. I won't play you this video, okay, because we'll be running out of time. But, okay, you can use the extended teacher guide to explore even further certain concepts. Okay, so just thinking now, if you could very quickly write in the chat box, which thinking and working scientifically sub-skills or sub-strand are they using here, okay, with this resource, okay? You can see that from the learner book in stage 5, this is, learners are given ideas for making a very simple model of the human stomach, okay? Very little teacher or parental guidance is needed here, okay, especially at stage 5 when we are aiming for our learners to become more independent. Now, you can see that they don't need a ready-made model because we can work it out visually with the diagram there, okay. In the TG, there's lots of support highlighting how to use the model so that learners develop an understanding in order to meet the learning objective, okay. Then learners can carry out the experiments themselves, either at home or in the classroom, following the guidance in the workbook. Now, I'll just have a quick look at the chat box. Okay, thinking outside the box, making a model and understanding. Thank you. Okay, I can't see who wrote that in, but apologies for not giving you credit earlier on that. Okay, now you may have other ideas to share, so please do write them in the chat box for other participants today to see. Okay, let's move on to another sub-strand, okay, and that was the answer. Okay, also planning scientific inquiry there. Okay, so here, okay, which sub-strand are we developing from thinking and working scientifically when learners are carrying out an investigation of pouring liquids, okay, and whether they pour quickly or slowly? Okay. So this is what has been suggested in the teacher guide. Let's have a look at your chat box. Okay, fair testing. Yes, analysis. Okay. Yes, it is scientific inquiry. Okay. All right. Analysis and evaluation, lovely. Drawing your conclusions, collecting and recording observations. Here, I will give you the resource, okay. Excuse me. And there, okay. So it's helping our learners to collect and record observations and measurements here by using this specific photocopiable master, okay. That is lovely, thank you. Okay, now, okay, this is these are two great visuals here. The one on the left is an interactive visual from the extended teacher guide, and it's actually drag and drop, okay. So yes, they are looking at models and representations of the water cycle, okay. Here, by them actually using the interactive really does engage them to think about the model of the water cycle. So okay, and I've taken it here, it's models and representations from stage 5. I took that one stage further, in fact, and I got them to carry out their own experiment, okay, but they had to plan it first of all, and then they had to analyze the results of, so they made their own model of the water cycle. Okay, so next I'm going to talk a bit about differentiation and thinking and working scientifically. I know that differentiation will cross many of your minds, and in many ways this strand is very much like a pot of gold, okay? You can choose to carry out the same investigations and vary the levels of independence that you're going to give your learners, or you could give some learners more support if they need it. Now, in terms of Collins resources or materials, the activities are differentiated in terms of demand, and they do grow in complexity. So you can decide which investigations you're going to carry out with your class. You know your learners best, okay? So the teacher guide will, here on the right, we have got symbols here for all most, and some learners, so really trying to extend some learners, okay? And we've also got differentiated activities within the student book. So next, okay, thinking about assessing TWS in the classroom, okay? We have to monitor the development of this important skill or strand. As you teach, you want to make sure your learners acquire the basic skills so that later on they can apply them in more complex situations. There's lots of opportunities within the teacher guide for you to identify assessment opportunities. By careful questioning, you can enable your learners to think like scientists, and this helps you to establish where they are in their understanding. And this is very much at the core of the Cambridge curriculum. Apologies here, because I can see that my highlighted boxes have been moved out of sync there. Okay, so next, okay, I would like to talk to you very quickly about language support for thinking and working scientifically. And that is because I am aware that a lot of our learners are English as a second language learners. And I would say that by its very nature, again, thinking and working scientifically helps learners develop competency in English. They're actively encouraged to talk with each other, to ask questions with each other, to find out more from each other. Within the student book, and the workbook, mainly, okay, we have got science or sentence frames, and we've also got glossaries. We've also got in the student book, we've got the keywords, okay. In the extended teacher guide, we have got an audio to the actual glossary of the key terms. We've got questions within the teacher guide as well, for example, for making predictions. What do you predict will happen? Draw your prediction. Were you correct? Okay, so getting them to use graphic organizers, as you can see, excuse me, as you saw from the one of the previous slides, we had a great template for organizing data, and then the use of diagrams. So visuals will help our learners understand concepts even more. So here I have got some frames or models for learners to follow. Now, a quick word about global perspectives and Collins science, okay. Global perspectives, if you teach it, okay, or okay, if you're new to it, it is a separate program. And within global perspectives, there are skills that are developed, such as research, analysis, evaluation, reflection, and collaboration. These are relevant to every student in the modern world. So it's not just in the Cambridge curriculum, but these skills can be applied in learners' everyday lives, okay? And you'll see also that these skills are embedded within the science curriculum too. Now, so the resources from Collins, okay, support global perspectives by including activities which develop and apply the skills. But note that the content is not intended to correlate directly with global perspective topics, okay, in terms of the challenges from global perspectives, but it rather encourages the practice and development of global perspectives to support you in integrating and embedding GP across the curriculum. So at the back of the teacher guide in each stage, here we've got it from stage 2, you can see the global perspectives skills have been listed and where they are taught in that particular stage. So which activities in the science book would cover the particular skills from GP. So that's good. Now, I don't have time to be going through a lesson walkthrough, okay? So as I very quickly whiz through, it's a lesson sprint through. I'd like to see if we've got some questions coming up in the Q&A box. You can see some fantastic resources here that we've got from the teacher guide, okay, and some of it is extended, okay. Let me go back. Okay, questions, please. Do we have any questions?
Any questions, anybody? Would you like to ask anything? Okay, Ms. Unnati has asked Ms. Parker, assessments linked to activities, and there's a question.
Right, okay. So the assessments linking to activities. So there are two different ways of thinking about this. Okay, we have got the formative or ongoing assessment in the classroom. You have got lots of opportunities or question frames for you to use yourselves as an activity is progressing. You have got evidence, say, from the experiments, okay, the investigations that the learners have been carrying out, and these are often recorded in the workbooks, okay. Now, getting that right result is not really what we're looking for, but we're looking for how a learner can explain their thinking process, okay? And that really does hit thinking and working scientifically. So is there another question?
Ms. Parker, there is a lot of requests, a lot of people have requested, if you can please walk them through one lesson plan.
You'd like me to go through the lesson plan?
Yeah, one lesson.
Okay then, right, okay, I'll go back then, okay. I mean, this is, right, okay, all right, okay, so this lesson is talking about the skeleton, okay, and it's from stage 4. Now, I was thinking about our thinking and working scientifically skills here. Now, you have probably seen it at speed already, okay, that lesson walkthrough, but which which TWS skill do you think we are developing in this particular lesson on the skeleton? Oops, gave you the answer. Now, let's have a look. If you could just write in the chat box, okay. Okay, and we're getting some great questions coming in here as well, which I will come to in a moment, okay.
So Ms. Anjum says inquiry.
Inquiry. Okay. Right.
Identifying and classifying.
Yes. Yeah, that's a really good point, actually. Yeah. Because this is where it's difficult to sometimes to strip the thinking and working scientifically substrands and to, even though it's more granular, but we are touching or using many different or many of those skills in our lessons, and in particular this lesson on the skeleton. Okay, so what Collins decided to do was to focus on particular ones each time. Okay, so here with the human skeleton, it's talking, it's really focusing on models and representations. Now, following the guidance in the teacher guide, okay, I get my learners to think about the differences between the ragdoll that you can see on the left, and I would sometimes get a young learner to sit on their chair, okay, and for them to be sitting either straight or they could be floppy like the ragdoll. Or I could get, if I haven't got a ragdoll, I would get one learner to be floppy and the other learner to be sitting normally. And I would get them to think of the differences. Okay, now you can be doing this online by getting them to fill in the chat box, or if it's face-to-face, hands up. Okay, then the question would be, what would it be like if we had no skeleton? And I'd get them to think of as many differences as possible within 2 minutes. Okay, and then afterwards I get them to brainstorm the ideas onto a flip chart. Okay, or a piece of paper, and then those, if they were working in groups, they could exchange flip charts and tick those they had in common. Okay, and you could have it tabulated like this: having a skeleton, not having a skeleton. My next question would be to them, what advantages does having a skeleton give us? Okay, and I would be eliciting from my learners protection, support, and allows us to move. Okay, I'll be giving them time to process that information. Next, before I show them the student book, I would get them to draw around. This is what's suggested in the teacher guide, and I think it's a lovely idea, okay, for them to be working in pairs and to draw around the outline of each other's body. Okay, and then I'd get them to draw the bones inside. After that, this is like working out what they already know. Okay, then I'd get them to look at the student book and compare. I might also ask them at this stage, before they see the student book, and that is ask them, which bones do you already know? Note, I think this is really important, that we don't use the Latin names, okay, for labeling the skeleton. And there are very few bones that are introduced at lower level, at primary level, okay? So they would have compared their drawings with the student book. I could then show them the interactive slide, and I could get them to come up and point to particular parts of the body. You can see here, I have on purpose done a matching activity or mismatching activity. So they would have to come up and correct the mistakes, or if I was doing screen share, they could circle the mistakes, okay? Next, I would be doing some differentiated activities. I'd have to think in my lesson plan how I'm going to structure this, how am I going to group my learners, okay? I think in terms of real time, I would give them about 15 minutes to do the differentiated activities. Now, the student book gives me some photographs of bones from museums, okay, and I'd be getting my students to think about the differences between old bones and new bones, or the bones that are in our body right now, okay? So the differences are that old bones crumble, they're very dry, whilst, and also they're very light, okay, compared to our bones, which are strong and hard, okay. Another differentiated activity is for them to be looking at an X-ray, okay, and we have got here a PowerPoint, okay, and asking them to think of the difference between a green stick, open and complete fracture, okay. Then the last differentiated activity is making a poster to advise what you do if you had to wear, if you did break a bone. So that is taking their knowledge one step further about trying to heal bones, okay. Students would have to do some research about that. So again, they're using another science inquiry skill here, okay, finding out what to do when you have a cast or a pot, okay, and how you would care for it. They would need to consider as well how best to present this information in a user-friendly way. Right, then with my plenary, again, the idea has come from the teacher guide. I could get my students to name the bones, okay. We could, if we're in a face-to-face classroom, do an activity which is called slap the board, and I'd have two learners standing at the front and to see which learner would be the first to slap the collarbone, slap the skull, slap the pelvis or the pelvic bone, okay. And then in my student book, okay, I've got
I'm so sorry, Siobhan, you're on mute.
Okay, that's great. Thank you. Okay, so at the bottom of each activity or of each page in the student book, at the end of the lesson, they have got a great I have learned section. So that is just getting learners to think about here in this instance, humans have bony skeletons inside their bodies. Skeletons are made of different bones connected to each other. The question for us really is, how do we know that our learners know this? Okay, and how do we measure that? Okay, is that through our questioning? Is it through evidence of learning? For example, here on the next slide, you could, for their homework, be getting them to label this human skeleton, and this is taken from the workbook. So that was a very quick walkthrough of the lesson. Next, okay, I would just like to recap about the learning objectives from the science curriculum. Okay, in the new curriculum framework, science is at the core with the learning objectives, okay, across all 4 content strands. Science and context links everything. Learners using the Collins materials will discover how science is present in their lives every day, okay, as you can see from this lovely learner doing her volcano experiment, okay, and the inquiry-based approach will ensure that learners think and work scientifically. So I know I had some questions, okay. We won't do the speed sharing with each other, but you can see here, this is an activity sometimes I use as a plenary with my learners, okay. By them talking about what they've learned in the lesson, it further reinforces or highlights to you if they have understood or not the main teaching point of the lesson, okay. And getting them to repeat it 4 or 5 times, each time you could shorten the amount of time as well, okay. Now, very quickly, before I say goodbye and enjoy, I'd like you to just have the link. Can you see that? Whoops, sorry. Yeah, school support at HarperCollins Co. India, okay, or in. If you have got some further questions or you would like to have some further support, let me just go to the chat box, okay.
So, Ms. Parker, this is a question from Mr. Swaroop. He has asked, are there examples connected to Indian contexts?
They're connected to international context. So Collins is very aware that we've got a diverse audience, really. So it's more international, and you can adapt what you think is appropriate or not appropriate to your context. So Collins has been very mindful of making it international. Now, even India is a huge country as well. And so it's very difficult to really kind of like hone in on a particular city or village. So we're mindful of that. There's another way of looking at it, and that is, okay, with the fantastic visuals and resources, additional resources, it's opening up the world to our learners as well, the wider world. Okay, so, okay, there's some great messages coming in here.
Yeah, thank you, Ms. Parker, for answering that question. Thank you so much. Ms. Anjum has asked a question. What is the right age of developing scientific temper?
Scientific
temper. The temperament. What is
the temperament?
Right?
The temperament. Yeah. And that's what I thought you said. Yeah, right from the very beginning. Okay, we want our learners, as you could see from that 5-year-old that you saw, the picture of her working like a scientist, or in fact the picture of the little boy who was doing the speed test and recording the data. So if again, we have pegged the kind of learning objectives to the age and what we'd be expecting our learners to be able to carry out reasonably according to their age. So that's a great question. Okay.
Thank you so much. Thank you
so much. I could go all day. Sorry, I could go all day talking about this.
Thank you so much, Ms. Parker, for answering that as well. So Mr. Daniel has asked, any online platforms to show the lab for higher grade students from 8 to 12?
From 8 to 12, online platforms. Okay, for showing, do you mean by a simulated lab? Okay.
Mr. Daniel, if you want to be unmuted. Yes, he's saying yes.
Okay, that's great.
Right.
Yeah, I think what I will do is get back to specifically, okay, with the links after this webinar. So if I feed it to you in India, okay, the links, if I email you those links, and if you could forward it either to all the participants or to
Thank you very much.
gentlemen. Okay, thank you for asking the question.
Simulations will be really helpful. Thank you very much.
Yes, yeah. Okay, and some other links as well. I know there's a very good website. Now let me show you. I did have, I can't remember, I think I've hidden the slide actually. You won't be able to see it. And that is, now I did have some websites, but I will actually show them or just share them with you later. Okay, I've hidden the slide and I won't be able to access that now. Okay, do we have any other questions?
Not really. Do you have any other question, anybody? Okay, so they are saying just that, if you can share the links because we are online as of now, and they would want it for primary as well as the secondary.
Yes, I will do that. Yes. So thank you very much, everybody, for joining us this evening. I'm very aware that it's the start of your weekend. You've worked very hard at school, no doubt, this week. And please go away and enjoy using Colin's resources for teaching science in the next year and years to come. It is, I think, it has made science a lot more enjoyable to teach. So I will take my leave now.
So thank you, Ms. Parker. Thank you so much, Ms. Parker, for an interactive and a very, very informative session. We are sure the participants found it interesting and know now how rich is the content and the resources available with us at HarperCollins. So thanks a lot. Thanks a lot. It was really brilliant.
Okay, thank you. Okay, I will leave. Okay.
Thank you so much, participants. Thank you, dear participants. And we wish you a very, very good evening, Ms. Parker.
Yeah, and the same to you. Okay, right. Okay, bye-bye, everyone, and thank you.
Bye, Mom. Thank
Bye.
you.